dimensionalization argument might not be necessarily the only thing to think about.
My name is Lisa Manning. I'm a professor in the physics department here at Syracuse University. So my research focuses on non-equilibrium materials, and we take a very broad view of the word materials. I study granular materials, which is important for understanding processing in pharmaceutical companies. We also study glasses, which are found all over in materials science. And then we also study biological tissues. It's only recently that we've realized that some simple or minimal models from physics can really make an impact in our understanding of biological tissues. So the Simons Investigator Award was a really exciting and happy surprise. As they say in the announcement, it gives me a standard base of funding so that I can work on high-risk, high-reward projects, whatever I think is interesting, without worrying about having to immediately explain what I'm doing on a year-to-year basis. So I can think longer term, I can think bigger picture, and I can really support the students and postdoctoral associates that are doing this type of work and make sure I can give them sort of a standard of support as well. It's also a very prestigious award, and it's not given out to very many people, and so it made me very excited because it indicated that my peers think that what I'm doing is important. With the Simons Investigator Award, they're really trying to fund people that they think are at the cutting edge of the field and making new discoveries that can really shift the paradigm of a field, I think, is their goal. I'm really excited about a couple of different directions. One direction is in thinking about cancer. In particular, I think some of the new mechanical models for tissues that we've been developing have a really exciting application in thinking about how cells behave inside cancer tumors, and also about thinking about how we might come up with new biomarkers for whether a cancer is invasive or not. So much of cancer is mechanical. In other words, cancer cells change their mechanical properties in very sort of interesting ways in order to become invasive or to become metastatic, which is where a cancer tumor sort of becomes problematic because the cells leave the tumor and go throughout your body. And so when you combine the best of the knowledge of biologists with the tools of physicists to understand how cells behave mechanically and how they can exit a tumor, that becomes really powerful.